The class. This is going to be the video for sections 10.3 and 10.4. In the book, 10.3 is perimeter, but they also do some like basic definition of polygons and just like names of objects. Uh, After I go through like just the perimeter and area problems from the lecture notes, I'll go into MyMathLab and show you some of those. It never hurts to review the vocabulary, so when we throw it at you, you know what we're talking about. But the reason I'm doing these together is when we tend to think of perimeter and area together. Normally we calculate it. Also, in the book, they don't start circles until 10.4 at the area. And so by combining those, I can get circles out earlier and kind of talk about it all together. So um, this might be a little bit longer video. Well, it'll be longer than 10.2. It's kind of going to be about a normal length video. Most of mine are around 45 minutes to an hour because I think in the homework there's like 25 to 28 questions. Some of them are perimeter, some of them are area. For the most part, the perimeter area problems are relatively straightforward. But then there's always going to be some that get a little bit messier, and we'll get into those. But so yeah, so this is 10.3 and 10.4. If you're following along in the lecture notes that I posted on Blackboard, the page 1 of the chapter 10 notes was the Pythagorean theorem. We're starting on page 2 of those notes. Get in there, get going. So like I said, in 10.3, that focuses on perimeter, which the perimeter is just the length around the outside of a two-dimensional object. We're going to get into surface area and get into volume and talk about 3D objects later, but we're in perimeter, we're just talking two-dimensional objects. One of the things to remember about perimeter and just in general for area and all the rest of them is make sure you have the right units. So if we're talking perimeter, we're talking length. And so length is always there's no exponents. It's just feet or just centimeters or just miles or just kilometers or miles, etc. There is no squared terms because if we're squaring something, we're talking about area. So area is the space inside that object, a two-dimensional object. So it's always centimeters squared, inches squared, and so on. Should be 10.4. In 10.5, we're going to get into surface area and volume. Now for the surface area, we're talking about the outside of a 3D object. And so basically that's going to be several single area calculations added together. So like if we have, for area, we might be finding the area of a rectangle. For surface area, we might be finding the area of a rectangular box. So a rectangular box has 6 faces. So we have to do like 6 area calculations in general. Okay. There's going to be a lot of formulas that are going to be given, but that's what surface area is. The outside, but it's area, so it's still going to be square. So we're still talking square centimeters, square inches, etc. And then we'll get into 10.4, we talk about volume. That's the 3D space. So since that's the 3-dimensional space, that's where we're going to be cubic. So cubic inches, cubic centimeters, and so on. So perimeter, no exponents. Area or surface area is squared units. Volume is cubic units. All right, so just a few names for things. Again, the homework has a few more that I'll get into when I'll bring up MyMathLab. So triangle, just 3 sides. A right triangle that we've already talked about with the Pythagorean theorem has to have a 90 degrees. That's when you see the little square in one corner. Rectangle, opposite sides are equal and all angles are 90. A square is just a rectangle where all sides are equal. So all squares are rectangles, but not all rectangles are squares. You've probably heard that before. A parallelogram it's basically a rectangle where all the angles are not 90 degrees, but the opposite sides are equal. And I say think of cardboard boxes have been squished. So like this will be a parallelogram. So like if you think like you push on this side of the rectangle, it like squishes it over. So for the most part, those works like rectangles. We do have to be a little bit careful about when we're doing area, and we'll get to that. I don't know if there's any trapezoid problems. A trapezoid is basically a rectangle where two of the sides don't have to are not parallel. So like the top and the bottom would be parallel, but like the left and the right are not parallel. Or all these you could rotate it. Um, so you could have something like that would be a trapezoid because these two sides are parallel, but those two are not. Those are all these all have rectangle, square, parallelogram, trapezoid. Those are all four-sided figures, so that's what we call a quadrilateral. Triangle for three, quad for four. Right. Then we have our circles. And so the thing with circles is you have to make sure you know the difference between the radius and the diameter. So radius is halfway across. So that would be the radius. Diameter is all the way across. And again, I have to go through the center. Yeah, and so most of our formulas with circles, we are dealing with R. So if you're given diameter in the picture, you have to know that the radius is either half the diameter, or sometimes the diameter is twice the radius. But most of the time, we're given diameter when you get radius, so you just take half of it. Something else with circles is pi is always going to be involved in all our formulas. For the most part, the problems in MyMathLab say use pi is 3.14. If they don't say that, then you can use your pi button on your calculator. These calculators, where is it? It actually has a pi button. Sometimes calculators with the pi button will be right above it. But one thing you don't want to do is if the problem says use pi equals 3.14, then don't use the pi button on your calculator because that has all the decimals. Because pi is 3.141529, it goes on forever. So if you're using all of those might throw your answer off enough for MyMathLab to count it wrong, mainly due to rounding issues. There's also some problems where they say get the answer in terms of pi, which you may have not seen before. So I'll definitely do examples on that. But in general, most of the time in MyMathLab, we're using 3.14 for pi. Right. And then just to review, rectangular box. That's pretty straightforward. All these can be rotated. Cylinder, that's like a Coke can. The one thing with cylinders is that we tend to label that height. The other thing you need to know is the radius. Those are the important measurements for cylinders. If we rotate it sideward, so it's a sideward cylinder, we still tend to call that height, even though now it's side to side. So just be aware of that. Yeah, on a rectangular box, we have the length and the width. Those are base and the height. Those are the length and the width. I like to use this because sometimes in rectangles we use base and height rather than length and width. But when we're doing three-dimensional objects, that height is kind of its own thing. So I like using length and width, not base and height for three-dimensional objects. For pyramids, one of the things for pyramids is often you'll see capital B. What capital B means is that's the base area. Like most of the time, I think our pyramids all are going to have either square or rectangular bases. They could have triangular bases. I don't think our homework problems have those. So anytime we're dealing with formulas for pyramids and you see that capital B, just know you kind of have to do a separate calculation to figure out what that area is, which would be, like I said, usually means you're going to have to find the area of a rectangle or an area of a square. If you had a circular base, then we no longer have a pyramid, we'd have a cone, which I don't know if we have cones in the homework. And just as a refresher, on that formula sheet that's posted in Blackboard for the test, the top was a lot of the conversions. On the bottom is all the geometry. So you can see all the geometry formulas I'm giving you, which is the vast majority of them. If there's something that's missing and you come across it in the homework, don't forget you are allowed one side of a page. And so, like I said, my in-person classes, typically what they'll do is, I give them this in class, and then they write the notes on the back. If you want to write more notes on the front to kind of get two full sides, that's up to you. But that's usually what my in-person classes do is print this off and then put their notes on the back. But again, you don't have to memorize your formulas. You just have to know how and when to use them. Right. And so, as we're doing perimeter area together, just to make sure that we're on the same page, capital P is perimeter. It's the sum of all outside edges. The only object that doesn't work for is the circle, because the circle just has one outside edge. And so that's where we need this formula. So the perimeter of a circle is called circumference, which is capital C. And so circumference of a circle, or the perimeter of a circle, is 2 pi. Okay, those are multiplication symbols, if that's coming across strange. Okay. Now, the way I remember that, as opposed to this area, the formula for the area of a circle is perimeter is always single units, so there is no exponent. Area is always squared units, so that's why there's a squared in the area circle, the circle area formula. Some other area formulas that you're going to see, area of a rectangle or a square or a parallelogram is length times width. A lot of people, again, use base times height. It's whichever you prefer. On a parallelogram, like I said, we're going to be a little bit careful to make sure that we're getting the right height, but we'll do an example of that. For a triangle, it's 1/2 base times height. One thing on these triangles is the height always has to be perpendicular. So if that's the base, that's the height, there has to be a right angle. If we have something that is like this, we need, this whole thing would be the base, that would be the height. So anytime you're doing a triangle area problem, you got to have that right angle measurements for your two sides, or for your two measurements. And then for area for circle is pi r squared. Now notice that neither of these have diameter in it. So if you are given a circle with diameter, just make sure that you take half the diameter, get the radius. Those are really the main formulas there. We might find the perimeter of a trapezoid, but I don't think we find the area of a trapezoid, which kind of has its own formula. So the main thing you have to be able to do is, one, read the instructions so you're answering the right question. And then two, make sure that if you're doing perimeter, you're adding up all the edges. Let's start with perimeter, and then we'll get into area. Okay, so find the perimeter of a polygon. Okay. Well, that's a triangle. We're given all three sides, so just add them up. Yes, it is that straightforward. Yeah. Again, that's kind of why I like to end with geometry, because most of the geometry stuff is kind of straightforward. Sometimes it does get a little messy, but not near, I think, as messy as like chapter 2 or unit 3. Okay. That's a big triangle, that's 61 miles around the outside. All right, what about 14? If we're finding perimeter, we need all the edges, but I'm only given 2. So what do you do? Well, first of all, this is a parallelogram, because the opposites. So when we're given something like this, you have to assume that the opposite sides are equal. So we're saying that's 8.9 meters. We're saying that's 6.8 meters. And so how do you find the perimeter? You have to add up all 4 edges. 8.9, 6.8, 8.9, 6.8. The order that you add them doesn't really matter. I like to pick one side, and I typically go clockwise just to make sure I get all of them. So add all those up, and there is our perimeter. So I'm getting 31.4 meters. Now, at some point, particularly if you're looking in examples or elsewhere, you might see for a rectangle, perimeter is 2L plus 2W. Well, where that's coming from is those two sides are the same, those two sides are the same. And so instead of writing out all 4 additions, They're just multiplying this times 2 and that times 2 before they add. That just sort of shortens this, but that's only for rectangles, squares, and parallelograms. Okay, so what's the perimeter of number 15? Well, we're only given one object. You may look at this and think, well, it's a rectangle, but one thing to kind of keep in the back of your mind, there is no guarantee that any of these figures are to scale. Like up here, that may look like a 90 degrees, but there is no symbol, so you can't assume it's 90 degrees. This may look like the sides are different, but since we only give you one measure, you have to assume that all four are the same. So now you're just, adding up 5 4 times. So 5 plus 5 plus 5 gives us a perimeter of 20. The perimeter's pretty straightforward until we start getting into some, kind of have to deliberately make perimeter messy. And the way we do that is start giving you something like this. Now, I apologize on the formatting. When you're in MyMathLab, it'll be easier to see like which measurement goes to which side because of the formatting issue of the program I'm using. It made it a little bit harder. But one thing you have to do is, we have to add up all the sides. So do we know all the sides? I know that's 22, that's 7. Now that one's 17. Now here is where it gets a little messy because of the formatting. That's 11, and then that is 14. And that's 4, that's 18, that's 22. So in this particular object, there are no missing sides. Because there's 1, 2, 3, 4, 5, 6, 7, 8 sides, and 1, 2, 3, 4, 5, 6, 7, 8 numbers. So all you do for the perimeter is just add them all up. And again, I like to, just to make sure I don't miss any, I like to pick a side and then go clockwise. That works for me. So 7 plus 17 plus 11 plus 14 plus 4 plus 18 plus 22 plus 22. That's it. Add those up right quick. Getting 115, what are we, meters? So it looks like a complex object, but there are no missing sides, so it's still a straightforward perimeter. Now here's where it gets a little messier. So if we look at this one, we have that's 24, that's 6. Now that is 6, but notice we don't know what that side is. We also don't know what that side is. We know the top is 7, and we don't know the right side. So there are 3 unknowns on this one. So we can't find the perimeter until we find all the sides. All right, so let's see. Well, what are the quicker ones to find? Well, if you look at the reason that they're putting 90 degrees, hopefully that car noise isn't coming through. So with all those 90-degree angles, they're basically telling you that is one big rectangle with like a missing spot. And so what that tells you, like opposite sides are the equal still applies. So that long side there is also 24. Now, if you look at this little rectangle, it also applies there. So that's 6 feet, says that is also 6 feet. That takes care of the quick ones. But what about this side? So how do we find the length here? All right, so on these objects, there's kind of 2 choices. Either you're missing a small piece. If you're missing a small piece, at some point we have to give you the total, or you're given all the small pieces and you don't know the total. So what do we do when we don't know one of the missing pieces? Well, we know the total, and this is where sometimes with these objects, you have to look at just horizontal or just vertical. So if I'm looking at just the horizontal, I know the entire horizontal side is 18. Now, up here, I have a 6 foot, an unknown, and a 7 foot. So what we do is we add those together, subtract from the total to get what's left over. So 6 plus 7 is 13. So 18 minus 13 is 5. So that tells us that that side is 5 feet. And again, that looks totally like if you're thinking it has to the scale is correct, that's going to throw you off because that is definitely drawn longer than those two sides, but it's shorter because the math. That's what the math tells us. That's what I mean that like these don't have to be to scale. But now once we know those three missing sides, now we're just doing perimeter. And now you just pick a spot, go through and add them all up. So you're going to be doing 6 plus 6 plus 5 plus 6 plus 7 plus 24 plus 18 plus 24. I don't think I need to add all those up because like figuring out those missing sides is really the key to this problem. All right, so let's see about number 18. So we're still finding perimeter. So that's 7, that's 21. Now again, I'm sorry for the formatting. That's 4.5. That's 10. We don't know that side, and that's 11. So how do we figure out this side? Well, first of all, for me, that's a vertical measurement. So I don't care about the horizontal. So right now, I don't care about the 21, the 10, or the 11. All I care about is vertical measures, which is 7 and 4.5. So how do we use those to figure out that missing side? Well, we know the total is 7, so these two have to add up to 7. So we just do 7 minus 4.5. That's 2.5. Now, the only other option was they would have gave us the 2.5 and we would have had to figure out the 7. If that's the case, you know the pieces, so you just add the pieces together to get the 7. But once you know that missing side, now you know all your sides. Perimeter is just this plus this plus this, all the way around. All right. Let's see. Before I find the perimeter of this object, since it involves a circle, let me jump forward in the notes. All right, so I'm jumping to the next page so we can deal with just a circle by itself. All right, so find the perimeter and area. Yeah. No, use pi is 3.14. So first of all, we need perimeter and we need area. So what is, for a circle, what is the formula for perimeter? Well, remember, perimeter is circumference for a circle, and that is 2 pi r. And an area is pi r squared. Now, is this the radius or is this the diameter? Well, it's only halfway across, so that's the radius. Now, here's where you have to be careful. It says answer in terms of pi. What does that mean? If it says answer in terms of pi, what they're telling you is do not substitute 3.14 for pi. Leave pi as the symbol pi. So when we're finding the perimeter or the circumference in terms of pi, so 2 pi r, we know r is 5 now. So you do 10, 5 times 2 is 10, and just leave it as pi. So that's 10 pi. That's what they mean in terms of pi, is do not plug in 3.14, leave pi as pi. Which I don't know about you, that fit seems really weird because we know what pi is, so I want to plug it in. That's when they say round to the nearest tenth, that's when we actually plug it in. So perimeter is 10 pi. So now we plug in pi is 3.14. Multiplying by 10, so that would be 31.4. Now, what are the units? Those are yards. Perimeter is a length. So those would be yards. Now, sometimes in MyMathLab, they'll put the units outside the answer box. Sometimes you have to know it. So just know perimeter is length, no exponents. How about area? Well, area is pi r squared. So now we know pi or r is 5. And so we always do exponents first. So we get square 5, so it gives us 25 pi. Now, if you want to substitute 3.14 in for pi, if you're doing it up here, you're going to get it wrong because it says it wants it in terms of pi. So that's actually our answer. And what are the units? Well, yard time is squared now because we're dealing with area. Yeah, we're squaring, that's 5 yards squared. So we're not only we're squaring the 5, but 25, we're squaring the yard to get yard squared. Okay. Now down here it says round to the nearest tenth. So now we actually get to plug 3.14 in for pi. 25 times 3.14. Now notice it says round to the nearest tenth, but in the answer, there's only a tenth. So that means there is no rounding. We wouldn't have to round unless there was at least 2 decimal places. This would be 78.5. Again, deal with area. So it'd be yards squared. And typically in MyMathLab, they have like separate answer box. If they don't give you the units outside the answer box, there'll be a separate answer box for both of those. All right. So how about 27? Same idea. We want the perimeter and area, and we want it in terms of pi and terms and rounded nearest tenth. But here's the problem is, we don't have radius. That's all the way across. So that's the diameter. So how do you find the radius? It's 1/2 the diameter. So it's 1/2 22. It'll be 11. So once you know that, then we're right back to what we did before. I'm just going to do perimeter because area is the same basic idea, just plug in a different formula. So for terms of pi, perimeter is circumference, so it's 2 pi r. We now know that r is 11. And since it says in terms of pi, do not plug in 3.14. Just do 22 pi. And we're in yards again. So 22 pi yards. Now it says round to the nearest tenth. Now we can actually plug in the pi is 11. Or sorry, the pi is 3.14. Sorry. So 22 times 3.14. Now this is 69.08. Need to round to the nearest tenth. So we're rounding to 0. 8 says rounded up to 1. So it'd be 69.1. We're still dealing with perimeter, so 69.1 yards. Area of the circle would be exactly like the previous example. So now we're using pi r squared. And so the only difference between this and number 26 is now radius is going to be 11. So like I said, but if we're given diameter, make sure for all circles, you always need the radius to plug into the formula. So if you're given diameter, take half of it, and then you're good to go. Now, not all the circle problems have this in terms of pi, but just watch out for it. Because that tends to frustrate people because I mean, just like you, I want to plug in pi 3.14, but for some reason they have you do it in 2 parts like this. Okay, so now let's back up to the previous problem with number 19. Find the perimeter of this figure. Approximate the result to the nearest tenth using 3.14 for pi. So none of this silly in terms of pi stuff. We just need, we'll get to plug in 3.14 for pi. So here's what I call, this is what I refer to as a compound object, because it has 2 objects together. It's a rectangle, and now this isn't a whole sphere, it's a hemisphere. And so a hemisphere is half of a sphere, or half of a, sorry, I jumped into 3-dimensional object. So if it was half of a, sphere is a 3-dimensional object. Sorry, I should have said semicircle. Yes, 2 dimensions here today, not 10. So a semicircle is half of a circle. So if we want the perimeter, we're still dealing with the outside. And so this is where, again, I would recommend breaking up into 2 parts. Let me go over to some blank space through here. And we have the semicircle. And then what we're going to do is we're going to add the perimeters together. So let's start with the rectangle. So what do we know about the rectangle? We know the bottom is 6 centimeters. We know the side is 8 centimeters. So what does that tell us about the rest of it? We know that's 8 centimeters. Now we know this is 6 centimeters, but here's a question. Do we need this 6 centimeters? Well, the reason I dotted it is that 6 centimeters, that top is not on the outside of the object. For perimeter, it's just the outside. So we don't need that 6 centimeters on the top. Just the only outside is the left and right on the bottom. So we just have 3 sides to add here. 14 and each 22. So for the 3 sides of that rectangle, perimeter is 22 centimeters. So now how about, that's a horrible circle. How do we find the perimeter of a circle? Well, circumference of a circle, which is perimeter, is 2 pi r. What is r? Well, because it was a rectangle, we know that's 6 centimeters. Okay. But here's the thing, that is all the way across. So that's your diameter. We know the diameter is 6 centimeters. We need the radius. So how do we get the radius? Well, we always take the radius is half the diameter. The radius is 3 centimeters. So the radius is 3. So now we can find the circumference. So the circumference is 2 times, and now we get to use pi is 3.14. Radius is 3. That comes out to 18.8 centimeters. But again, one thing to remember is we only have half a circle. We just need half. So we got to divide this by 2. We're not going all the way around the circle. We're just going around half the circle. 9.42 centimeters. Which if you've done a couple of these, then if we multiplied by 2, divided by 2, so we could have like taken out the 2 there. But it doesn't hurt to like find the circumference of the whole circle first, and then just know that we're dealing with half the circle, so divide by 2. So what is our final answer? Well, we want the perimeter of the object. So we want the outside. So we know the perimeter of the top of this semicircle is 9.42 centimeters. We know the perimeter of the 3 sides of the rectangle is 22 centimeters. So just add those together. So 31.42 centimeters. All right. So that's how we would make perimeter hard, I guess, or as hard as it's going to get. Is you're going to have objects that are going to have missing sides, and you have to figure those out. Or we're going to have a compound object, and you're going to have to figure out like the perimeter of each object separately, and keeping track like we're only dealing with the outside, not the inside. So these are the high-end perimeter problems on this page. That's perimeter. All right. So what about area? We get a little bleed in from the previous side. Apologize for that. But we have a rectangle that's 22 meters times 25 meters. What is the formula for area of a perimeter? Length times width, or base times height if you prefer. So you're just doing 25 times 22. So that's 550. Now, what are the units? We're doing meters times meters, because we're multiplying 25 meters times 22 meters. So that gives you meters squared. Your units for area are always squared. All right. What about 21? We have a triangle. We're trying to find the area of a triangle. What is the formula for the area of the triangle? I could say if you don't know it yet, shame on you, but I'd be joking. Bowl is, don't forget. Where are we? So area of a triangle is 1/2 base times height. All right, which one is base? Which one is height? Well, we tend to use the base as the bottom, but it doesn't really matter which one's which, but we need both of them. So it'd be 1/2 times 23 feet times 20 feet. And then we just do the arithmetic. So 1/2 times 20 is 10, so that would be 230. Now, what are the units? Well, we're doing feet times feet. So that gives us feet squared. Basically, again, area units are always squared. All right, what about 22? Now, this is a square. So depending on where you look, I mean, I prefer just treating squares as rectangles. So I would still say length times width. And just know, that the length and the width are the same. Sometimes for squares, you might see S squared. If you see that, they're talking about the side squared. So they're just acknowledging basically the length and the width are the same. Either way, we're just doing 8.8 times 8.8. That's 77.44. Miles times miles would be miles squared. Or if they wanted you round to the nearest tenth, which MyMathLab, watch those instructions to MyMathLab. The 4 is what we're rounding. That would say keep it the same. So it could be 77.4 miles squared if they wanted to round it to the nearest 10. Like I said, for these basic objects, area is, again, as long as you know your formula, which you're going to be given the formulas, pretty straightforward. Now, parallelogram, a little bit different. So if we want to find the area here, question is, well, it's still a rectangle, so it's still length times width, or base times height, whichever you prefer. But what measurements are we using? Well, the base or the length is 30.34 kilometers. So I guess we're doing outside stuff again. So do we use the 0.01 or do we use the 0.25? Well, for a perimeter, or sorry, for a parallelogram, you need that perpendicular. That is the height. The only time we would need that slant edge if you're doing perimeter and you want the outside. Now, the best way to explain that is on a parallelogram. Basically, if you take this and cut it off here, you can actually move it over and it would fit there, make a rectangle. That's why, like I said, I think of a parallelogram as a squished rectangle. So that is not the height, that is just the length of the slanted edge. You need that for perimeter, we need this for area. It's going to be 0.34 times 0.01. So 0.0034 kilometers times kilometers gives me kilometers squared. All right, so a parallelogram, just be careful with that and use the perpendicular heights for the area. All right, I think that was straightforward. 25 is kind of the same thing with the triangle. So if we're trying to find the area of the triangle, it's 1/2 base times height. What is the base and what is the height? Again, we need those that are perpendicular to each other. So that 23 would be something that we might need for a perimeter, but it's not perpendicular to either of these, so we need those two measures. It'd be 1/2 times 33 times 20. So that would be 1/2 20 is 10, 10 times 33, so 330 inches times inches, so inches squared. Yeah. So an area, you got to be a little bit more careful with your parallelograms and your triangles. Make sure you're getting those perpendicular lengths for your base and your height. All right. The other way that we can make area a little bit harder is give you, again, these compound figures. So let's do 28. Okay. So if we're going to find the area of this, my recommendation is we have a triangle and we have a rectangle. So let's split it up and find each one. Well, what do we know about these objects? Okay. Well, if that's 15, that's also 15, which that side is that dash side, so we know that is 15. Now we have to assume that's a rectangle, and if that's a rectangle, then that's also 90 degrees. So that means we are dealing with a 90-degree angle there. What else do we know? We know that top is 7 centimeters. What do we do with that 23? Well, these two together add up to 23. So what does that tell us? Well, opposite sides are the same. So that little piece is 7 centimeters. What does it tell us about this piece? Well, you know the total is 23. One part is 7. So that leftover is 16 centimeters. So that's sort of I guess the hard part, or maybe not the hard part, the setup on being able to do this successfully is splitting this up properly and labeling correctly. Here's your sides. Because once you know this, the area of a triangle is 1/2 base times height. That's 1/2 of 16 times 15. And then over here, area of the rectangle is length times width. So that's just 7 times 15. Now we just do the arithmetic. What's 120? So that's 120 plus 105. So that is 225. And then what are the units? We're dealing with centimeters. It's area, so it'd be centimeters squared. All right. So that's how I would do this one, is split it up into the rectangle and the triangle. How about 30? Okay, so on something like 30, you sort of have two options. You can split it up into individual pieces. Like on this one, we probably have like rectangle number 1, rectangle number 2, rectangle number 3. That's one way you could do it. And I'm going to do this both ways because one way might work better for some people than the other. The other thing you can do is you have an outside rectangle that's missing an inner rectangle. So if you look at it that way, we need like the overall rectangle, and then we need to subtract what's missing. Okay. So let me do it both ways, and that way, hopefully one of the two ways will help. All right, and we also know this is 11 and 2. Okay. All right, so way number 1, I'm going to do this in 3 separate rectangles. Split up into 3 rectangles. Like if you had an L shape, then you could split up into 2 rectangles. But again, the key on splitting it up this way, you got to know all your sides. Because if you don't know your sides, then it's kind of hard to do length times width, right? Okay, so let's look at this top one. So what do we know about it? We know the top is 4 yards. Okay, and then we also know the side is 4 yards. Do we need to know anything else? Well, we're not looking for perimeter, so I don't need the edges. We're just doing area, which is length times width. So that's just 4 times 4, which is 16. We'll do yards times yards, so yards squared. So that first rectangle, pretty straightforward. Let's go ahead and do rectangle number 3, because I think that one's also going to be pretty straightforward. Because now we know it's 5 yards on top. but it's still the same height. So it's 5 times 4. So that second rectangle is 20 square yards. All right, so what about the big rectangle, rectangle number 2? So what do we know? Well, we know the bottom is 11 yards. That's that's given in the problem. And so now we need the height. Okay, it's not 16 because that 16 is the whole thing. But we know the little piece is 4 yards. So since we know the big piece and one of the pieces, then the remaining we just subtract. So that's going to be 16 minus 4 or 12 yards. So this is sort of the same idea we talked about with the perimeter. Since we know the big one, then you're going to use subtraction. And once we know that, then it's just another straightforward calculation of length times width. So 11 times 12, 23, so 132. So now we have the 3 pieces. And so now we just total them up. 16 plus 20 plus 132 for 168 square yards. So these compound figures, you can always split them up into smaller pieces and then just add them up. Right. Let's look at it the other way of like we have a big rectangle missing a smaller rectangle. How would that work? Again, that way also works for some people. Okay, so let me draw this. So we're missing a piece of it. So what we're going to do is we need the big piece, and then we need the missing piece. So what do we know about this rectangle? Well, we know the bottom is 11. We know the side is 16. So isn't that our big piece right there? Because that's the whole thing. So right that this area is quick to calculate. So the big area is 176 yards square. Okay. Now we need to figure out the missing piece. So what are the dimensions of this missing piece? We go back to the original figure. We know that the side is 4. So we know the vertical side is 4. What's the horizontal side? So if we go back to the original drawing, we know that overall, that's the 11 yards. Okay. We know this is 4. We know this is 5, which means this is 4 and this is 5. So we don't know that piece. Well, if we know the total is 11 and we know those two sides, so those are 9. 11 minus 9 gives us 2. That tells us that is 2 yards. So now we know the size of the missing piece. There is 4 times 2, which is 8 square yards. So how does this help us? Well, we know the outer area, or the area of if it was a full rectangle, it'd be 176. We know the missing piece is 8 yards. So now to get the final answer, since we're missing a piece, we're going to subtract. That gives us 168 squared, which Yes, that matches the answer we got before when we split it all up into little pieces and added them together. All right. So like I said, for some people, splitting it up into smaller pieces works. Some people splitting it up into a big piece minus the missing piece. Whatever works for you, we should get the same answer either way. But both of them require you to figure out like missing sides. That's kind of the challenge there is pick a way and go with it and then know what your sides are. All right. Note. I'm not going to do 29, but let's talk through it right quick. So here we're finding the area of the figure. So before we had a similar problem where we needed the perimeter. Now we need the area. Well, this one might be even quicker in perimeter because how do you find the area of the rectangle? Well, that's just length times width. That's 4 times 6. So that's quick. How do we find the area of that? Well, this is half a circle. Area of a circle is pi r squared, but we only want half of it. We got to divide by 2. And the other thing is we need the radius. So what's the radius of this circle? Well, we know all the way across is 4. So halfway across is 2. So there's your radius. So find these separately and then add them together. All right. Again, I really wish I could pause and get questions. But since I can't, I just have to do what I want to do. I want to go into MyMathLab and show you some other things that are we didn't cover here. So like I said, this one's 26 questions because it is two sections put together, 10.3 and 10.4. So you have one slightly longer one instead of two shorter ones. Yeah. So one of the things is from the 10.3 in particular, they do definitely some like naming stuff. So a polygon is just any object, like all these objects we're dealing with other than circles, a polygon because it all it has sides. So a four-sided polygon. Well, look for the prefixes. Which one of these means four-sided? Well, 4 is quadrilateral. Five-sided, quad is 4. Octa is 8. Pentagon, penta is 5. Six-sided, that is our, like a stop sign. That's hexagon. Seven-sided is hepta. And then 8 is octagon. Let me make sure I didn't get those two backwards. Yeah, we're good. So again, this is just, and again, anytime you're looking for definitions, um, and you're not finding them because like we didn't cover this in the notes, don't forget there is that textbook option in the homework. And so that's a great place to go for answers. Just go to the textbook because I don't have all of this, A polygon whose sides are all the same length and whose angles have the same measure. Let's look at that. Quadrilateral, just that would have to have 4. That would have to have 3 sides, 8 sides. So those don't make sense just based on what they are. So if they all are the same length and all the angles are the same, that's what we call a regular polygon. And again, the reason I'm giving you these is because if it pops up in the homework, then you'll have to, like in the later problem, you'll know what they're talking about. So opposite sides of a parallelogram. Well, remember a parallelogram is basically a squished rectangle. So just like a rectangle, the opposite sides are equal. So opposite sides of parallelogram are also equal. And well, it's a parallelogram. So the opposite sides are parallel. A four-sided figure with exactly one pair of parallel sides. Um, so it can't be a rectangle because both sides are parallel. Same with a square. This is in between a rhombus and a square. A rhombus actually doesn't have anything that's parallel, so this would be a trapezoid. A rhombus is like a diamond. The perimeter, I think I mentioned this once. For a rectangle is twice the length plus twice the width because the opposite sides are the same. So instead of saying L plus L, you can just do 2L, and the same with the W. That's one of those formulas that if you know it, great, might save you a little bit of addition, but it's pretty straightforward. Um, And this is what I was talking about is sometimes in MyMathLab, they'll have two answer boxes. So the first answer box is your number answer when you add all those up. And then the second answer box is for the units. We're talking perimeter and talking centimeters. I don't even know why. They should probably have just centimeter squared. That's usually the two answers we get. Perimeter is never squared, so we're talking centimeters, we're dealing with centimeters. So that's like the newer stuff. The one thing I didn't go over was like the how to like name the particular objects. Let's see. Find the perimeter of the regular heptagon. Express the perimeter using the same measure. Well, that means, since we're talking millimeters, we're talking millimeters. So how do you get the perimeter here? Well, remember regular, that regular polygon says all the sides are the same. So since I'm only giving you one side, they're implying that every single side is 12. And a heptagon means you have 1, 2, 3, 4, 5, 6, 7 sides. So you're basically adding 12 7 times or doing 7 times 12. All right. So we talked about those. Yeah, so that's the perimeter style stuff. And then we get into area, and I think we covered all the area things. Area of a trapezoid. Oh, we didn't cover this. I should probably so I know that I didn't realize this was in the homework. The area of a trapezoid is one half is one half height times AB. So normally, trapezoid is a quadrilateral. So if you think of it as the area of a rectangle is just length times width. The problem is with a trapezoid, the the opposite sides are not the same. So this A plus B and that one half, they're basically taking the average of the two sides that are not parallel. So that's the height is like, that's base times height, there's your height, and then you got to do a little bit of work to get the base, basically. Let's see. Like I said, I don't remember there being any homework problems where we actually had a trapezoid area. Let's see. Yeah, but other than that, that looks pretty straightforward. Like here, we talked about this. Like here is your triangle. Area of a triangle is one half base times height. And so what measurements are you going to use? Well, anytime you're trying to find area, you need the perpendicular measurements. So what you'd actually be using is the 7.9 and the 2.3, because those are the ones that are perpendicular. That's your base, that's your height. So even though that doesn't extend all the way there, the formula takes care of the issue, right? So that you need those perpendicular measures to plug into your formula. And on the units, we are doing area because we're doing, yards times yards, so it will be yards squared. And I warned you about this. Find the circumference in terms of pi. So when it says in terms of pi, do not plug in 3.14, just leave pi as pi. Once you put in the answer here, what is that? It's 2 pi r, so 14 pi. And then in the button down here, they have the pi symbol. And that is area, so it'd be centimeters squared. So once you get, oh, what did I do incorrect? 2 pi. This is what happens when I try to do something. Let me get this right quick. So circumference is 2 pi r. We know radius is 7, so that'd be 14 pi. What am I missing? Okay, I think it's time for me to be done with videos for the day. Oh, see, circumference is length. Yeah, I think it's time for me to go eat lunch. So length, circumference is outside. That's not area, it's length. So I was putting in centimeters squared, but it's just centimeters. The only reason it would be squared if we were doing area. But this is, I was so focused on the in terms of pi, I wasn't paying attention to the rest of it. I apologize. But now on the next one, and I got the 14 because it's 2 pi r, so 2 times 7 gives me the 14. Now when it says to the nearest tenth, now you come back up here and plug in 3.14 for pi. So do 14 times 3.14. That would be the number you put there. All right, again, I don't know why they do that with circles. That's something this author has done for years. I've never figured out why. So, all right, this is 10.3 and 10.4. So really, there's actually only one video left, which is 10.5, which is volume and surface area. And then that's it for test 4. It's just chapter 9 and chapter 10. All right. So that is it for today. I'll see you soon for the next topic.